This lesson looks at vertical and adjacent angles. We want to know how to find the measure of vertical angles. Knowing about the relationships with adjacent angles can help us to do that. So let's first take a look at adjacent angles. Being adjacent means that they are next to each other. Adjacent angles are those, remember, that share a common side and a common vertex. A pair of adjacent angles in the figure below would be angle DPC and angle CPB. Find another example for some extra practice for yourself. Alright, so how in the world are adjacent angles going to help us find measures of vertical angles? Vertical angles, remember, are those that are opposite each other whose sides are intersecting lines. The vertical angles in this figure then are angles 1 and 3, angles 2 and 4. Now you find the adjacent angles. Hopefully, angle 1 and angle 4 was a choice, angle 2 and angle 3 was a choice. You could have also had angle 1 and angle 2, and angle 3 and angle 4. Here we're asked to find the angle measures. We want to know the sum of the measure of angle Q and the measure of angle T, and then we're going to look at the measure of angle T plus the measure of angle S. In order to do this, we just need to know what the relationships between these two sets of angle pairs are. Both pairs are adjacent and supplementary. Q and T are next to each other and they make up this straight line, and R and S do the same thing. We know that this is called a linear pair, and therefore Q and T and R and S and T and S will also all sum to 180 degrees. If the measure of angle T is equal to 37 degrees, what is the measure of angle Q? We already determined that T and Q are supplementary, so the measure of angle T plus the measure of angle Q must equal 180. So 180 minus 37 is equal to the measure of angle Q, which makes Q 143 degrees. Pause the video and do this same process to find the measure of angle R and the measure of angle S. Here's another practice problem for you. We want to find the missing angle measures. All we are given is that the measure of angle 1 is equal to 50 degrees. So there's 3 missing angles. Angle 1 and angle 2 are adjacent. They are supplementary because they make this straight line here. So then the measure of angle 2 must equal 130 degrees, so that those will sum to 180. Here, 2 and 3 are also adjacent, so 3 is equal to 50 degrees, so that this sums to 180. And 3 and 4 are adjacent, so this must be 130 degrees. What do you notice about the measures of the vertical angles? We have 50 degrees here, we determined this was 50, and then 2 and 4 are both 130. So each of those pairs are congruent angles. By using adjacent angles, we can see that vertical angles are congruent. Here we're asked to determine the missing angle measures. In order to do that, we have to find what the value of x is. We know that this angle here is 140 degrees. This over here is vertical to that 140 degree angle. So x minus 28 plus x, these two smaller angles, have to make up that larger angle that's equal to 140. So if we set up our equation as x minus 28 plus x equals 140, then we get 2x minus 28 equals 140, 2x is equal to 168, therefore x is equal to 84. So the missing angles are 84 degrees here and 56 degrees here. When we check this, it sums to 140 degrees and is congruent with its vertical angle pair. Hopefully, you've noticed some patterns in each of the examples that we've done so far. The vertical angles in the first one were 37 or 143 degrees. In the second, they were 50 or 130, depending on which pair you were looking at. And in the third, they were 140. So these examples show us that vertical angles are congruent and that adjacent angles are supplementary. But be careful with the adjacent angles conclusion, because remember, we've only looked at those where they form straight lines.